Okay, here are quiz 5 solutions for Math 111. On this quiz, we're going to go over function transformations and then later function composition. But first things first, transformations. I give you the graph of a function here, give it to you twice. You might be able to come up with what function this is here. You might recognize a parabola with some transformation. I don't want you to do any of that. I just want you to say this thing right here, this weird picture, that's f of x, fine. And what I want you to draw is negative f of x minus 2. So what I want you to do is recognize that I already have a graph of f of x. So this negative does something to it and this minus 2 does something to it. And if you can figure out what somethings those are, you can draw the new graph. So really the key to this is recognizing that in this first problem we have two vertical transformations. This negative right here is going to make me multiply all of my y values by -1. Some books will say that you're going to reflect over the x-axis. That's true. I think it's easier to just multiply all the y values by -1. That's what this negative does right here. The y values because I'm affecting the f of x, not the x. If there's a negative in front of this x, kind of like there is down here, something different is going to happen. But since it's the f of x, it's the y values that I'm multiplying by -1. Then this minus 2 right here just means that I'm going to subtract 2 from all my y values. And again, I'm doing it to, I guess that says values. Try again. Values. I'm doing it to the y values because it's the f of x that I want to subtract 2 from, not the x like you see down here. So I got these two vertical transformations. The order that you do them in is very important. With vertical transformation, things kind of work out as you would expect them to. You'd expect to multiply before you subtract, kind of going in order of operations. So you'd expect it to be 1 and then 2, and in fact, that's what happens. So what I'm going to do is I'm going to look at these 4 points, and instead of reflecting and shifting, I'm going to multiply my y values by -1. So this y value right here is 1, and this y value is 1, this y value is 2, and this is -2. And if I take each of those y values and multiply by -1, this height used to be 1, now it's -1. This height used to be 2, now it's -2. This height used to be 1, it's -1. This height used to be -2, and because -2 times -1 is +2, it's now going to be up here. And you can fill those in with the line and try to match this curve if you want. Well, I'm not going to bother because that's not my final answer. That's just taking care of the first transformation. I then have to subtract 2 from each of these y values. So from here, my height is currently 2. I want to subtract 2 from 2. That'll bring me down here to 0. I'll make that one big because it's part of my final answer. This one, the height is currently -1. -1 minus 2 is -3. -2 minus 2 is -4. And -1 minus 2, as we already said, is -3. These big blue dots are going to be on my final answer. And so what I'll do is I'll just try my best to connect those with the curve that kind of matches the shape of this guy up here. And then I'm going to call that good. I think that's the answer for number 1. For number 2, or I guess number B, B's not a number, but you get the point. Similar. I start out with this graph, which is f of x, that's stated in the problem. Now I got some transformations. In this case, both of my transformations are horizontal transformations. How do I know they're horizontal transformations? Because I am changing the x value, not the f of x value. What am I doing to that x value? Well, I'm multiplying it by -1, and I'm subtracting 2 from it. So you're like, oh, right, I got this. So first you multiply by -1, then you subtract 2. No, no, and no. One of those 3 no's is the order. You'd think you do multiplication before what looks like subtraction, but you don't. Horizontal transformations, everything's the opposite of what you'd expect. So I'm actually going to take care of this one first, this -2 right here. Now, okay, fine, you're going to take care of that, but you're going to subtract 2 from all of the x values. Nope, still not right. I'm actually going to add 2 to all the x values. I'm going to first, maybe I'll write subtract -2, aka add 2, to all x values. So not only is the order kind of counterintuitive, but what I do is counterintuitive. Instead of subtracting 2 from the x's, I'm going to add 2 to the x's. So this x coordinate right here is -4. -1, 2, 3, 4. -4 plus 2 is -2. This guy's going to go here. Note the height doesn't change at all because I'm not applying a vertical transformation. I'm just applying a horizontal transformation. By that same logic, this guy goes over here, this guy goes over here, and this guy goes over here. I'm going to add 2 to all the x values. That takes care of this transformation. Now I'm going to consider this one. It looks like you multiply by -1. Well, in fact you do, but I'm going to write it a little bit differently. I'm going to write you divide all x values. That's not all. You're going to divide all x values by -1. Why that's important is because if this were -2x, you'd have to divide by -2. You got kind of lucky that it's -1 because if you forget to divide and instead multiply, multiplying by -1 is the same as dividing by -1, so it makes no difference. But just be careful to make this work for more than just this specific problem. I'm going to divide all my x values by -1. So this x value right here is -2. Not because of this -2, but because of this -2. The x value right here is -2. -2 divided by -1 is +2. This is a big dot because it's going to be my final answer. This guy, remember it started here and went over here. You can't even see it because it's on top of where a dot started. Currently has an x value of -1. -1 divided by -1 is +1. Now I'm covering up this point that used to be here, so I better transform this one before I forget that it's there. I had 1 at 1. 1 divided by -1 is -1. So the path that we took was a little bit confusing there. Point started here, shifted to here, flipped over to there. And then a different point started here, shifted to here, and then flipped back over here. Okay, and then finally this point right here, well, its x-coordinate is currently 0, and 0 divided by -1 is still 0. So this guy right here is going to be on my final graph, and if I connect the big dots, I get a graph that looks something like that. Okay, I probably could have done this. The nice thing about this problem is you can make a couple mistakes and still get the right answer kind of accidentally. So make sure you understand why we're doing all the things we're doing and why I'm writing them in this order. Okay, moving on. Function composition. First, you're told what f of x is and what g of x is, and asked to find this huge mess here. What I prefer to do is rewrite this problem. See if I can get the parentheses right. Instead of f of g of f of 0, I write f of g of f of 0. I write it in this parenthesis notation because I think this is easier to deal with. Because when I see all these parentheses, I just think, all right, let's start in the middle here. Let's figure out what f of 0 is. So don't even worry about this f or this g or this g. Just figure out what f of 0 is, this guy right here. How do you figure out f of 0? Well, this is f of x. So I can figure out f of 0. Sure, I'll write it. F of 0 is just taking this function and everywhere you see an x, changing it into a 0. So 1 over 0 squared minus 1, aka 1 over -1, aka -1. F of 0 is equal to -1, so instead of writing f of 0 right here, I'll write -1. So that's it? That's my answer? Well, no, but now instead of having 4 functions nested inside each other, you only have 3. So repeat that a few more times and you'll be good. Now I want f of g of something. What is that something? Well, that something's g of -1. What's g of -1? Let's work it out to the side here. I know that g of x is 2x minus 1. So g of -1 would be 2 times -1 minus 1. -2 minus 1 more sounds like -3 to me. So instead of writing g of -1 right here, I'll write -3. Okay. So now I want f of something. That something is g of -3. Well, g of -3 is just 2 times -3 minus 1, which I believe is -7, right? 2 times -3 is -6, minus 1 more is -7. So instead of writing g of -3, I can write -7. And now if I can figure out f of -7, I'm done with this problem. Figure out f of -7, well, I know f of x. So f of -7 is going to look a lot like this guy, except everywhere I see an x, I'm going to write -7. So let's see, 7 squared, well, -7 squared is positive 49. And 49 minus 1 is 48. So f of g of f of 0 ends up being 1/48. Okay. What about f of gx? the idea here is a lot like the idea here. I'm going to first rewrite it in this parenthesis notation because I like this parenthesis notation. And I'm going to start from the inside. Up here I figured out f of 0 first. Down here I'm going to figure out g of x first. How are you going to figure out g of x? You're just going to look right here because it's given to you. G of x is 2x minus 1. So although the question asks what is f of g of x, you can think about it as just asking what is f of 2x minus 1 because g of x is 2x minus 1. And f of 2x minus 1, you can figure that out because you know what f of x is. And if you know what f of x is, you can figure out f of anything you want. Just replace all the x's in this equation with whatever's inside this parenthesis. What I'm saying is f of 2x minus 1 is 1 divided by 2x minus 1 squared minus 1. This is a perfectly acceptable answer. I'll even put a box around it to emphasize that. If you're the type that likes to FOIL, you can say 2x minus 1 squared is 4x squared minus 4x plus 1. But 4x squared minus 4x plus 1 minus 1 will just leave you with 4x squared minus 4x. Either one of these are totally fine. I don't care where you leave it. Okay, moving on to C. Find the domain of that thing. Like, the domain, nice. I know how to do the domain. I just got to make sure I don't divide by 0 and I don't take the square root of a negative number. True, but be a little bit careful. You want to consider the domain of two things, both your composite function and your inner function. It's important that you consider the domain of both the composite function and the inner function, g being the inner function in this case. However, you got a little bit lucky because if you look at g of x, 2x minus 1, there's no values of x that will make me divide by 0, no values of x that will make me take the square root of a negative number. So, fortunately for you, the domain of g of x is just everything from negative infinity to infinity, meaning all numbers work in this machine. We don't have to kick anything out from here. So I do have to consider the domain of this guy, but if you forgot that you also have to consider the domain of the inside function, it doesn't hurt you because we don't lose anything by looking at the domain of the inside function. I promise you that won't always be the case. I promise you on the final exam or at some point in this class, I'll give you one where you lose numbers both for the inside function and the composite function. So make sure you understand what I'm talking about there. Domain of this guy, well, I got to make sure I don't divide by 0. Maybe I should switch colors. So sure, I can make that say domain. Domain of this guy, well, I'm not going to take the square root of a negative number because I don't see any square root signs. So really, I just have to make sure that 4x squared minus 4x does not equal 0. Well, let's figure out when it does equal 0. Because if I can figure out when it does equal 0, then those will be the numbers that are not in the domain. How do you solve this equation? A couple options. I think the easiest way is to factor out a 4x. Because now you've rewritten this as something times something else equals 0. It's a good thing because the only way in math you can multiply together two guys and get 0 is if either the first one is 0 or the second one is 0. So you change this one quadratic equation into two different linear equations that you can solve, divide both sides by 4, or add 1 to both sides of the equation. So the domain is all x except 0 and 1. Fine. That's the domain of this function. You then say, okay, I'm kicking out 0 and 1 here. I also have to see what I kick out over here. Oh, right, I didn't kick out anything over here. In this case, it just ends up being that, which you can write as everything from negative infinity all the way up to 0, union, everything from 0 all the way up to 1, union, everything from 1 up to infinity. This is perfectly good. Any of this stuff is good. And that ends up being the answer to this, and I guess that kind of ends the quiz, so I'll stop the video here.